Our respected Vice Chairperson, Niti Aayog, members Niti, CEO Niti Aayog, Secretaries, Government of India, and all other dignitaries. A very good morning to all of you, and good afternoon, to all of you. And it is a tremendous pleasure and a privilege to welcome you all to the inaugural session of Niti Frontier Tech Gurukul. This initiative aims to bring together the brightest minds in technology globally and the government to foster essential conversations about the use of frontier technologies for inclusive growth and nation development. So, as after spending 3 decades in the tech industry, I have to say this is such an honor to work with Niti Aayog to establish the Frontier Tech Hub. We have left a brief overview of the Tech Hub on the table for you to go through. And speaking of exceptional minds, I am so thrilled to introduce the first guest speaker for our Gurukul session, Yann LeCun, who's the Chief AI Scientist at Meta. And I wanted to say a few words about Yann for those of you who may not know enough about him. But Yann has been pushing the envelope on AI since he was in college. His PhD thesis, many of you may not know, but his PhD thesis in 1987 was on a version of back propagation, which was a way to train neural networks, which today is the foundational for training any modern neural network. That's what AI is getting built on. And right after, I think this, Yann was faced with the AI winter, when interest and funding in AI significantly went down. But right through all of this, Yann has advocated for the potential of artificial neural networks. He strongly believed that these networks could emulate human brain functions, allowing computers to learn and develop skills beyond manual programming, despite very strong skepticism from the computer scientists who pretty much at that time believed that neural networks were science fiction. In fact, Geoffrey Hinton has described Yann as as somebody who carried the torch through the dark ages. And along with Hinton, Yoshua Ben-Gvir, Yann is referred to as the 3 Musketeers of deep learning. And in 2018, these 3 Musketeers received the ATM Turing Award for their groundbreaking work in deep learning. This award is the real Nobel Prize for computing. And we are really proud to have Yann, who is today Chief AI Scientist, Meta, one of the strongest advocates for open source AI, and also one of the most honest voices you will hear in the world of AI. In his own words, he believes that today's LLMs that is driving the AI revolution are even more dumb than a cat. But he strongly believes that the future of AI is very bright and the best is yet to come. So I would love to kick off by inviting Secretary Mighty, Mr. Krishnan, to say a few words about India's AI ambitions and how we are thinking about AI.
I'd like to thank the Vice Chairperson and CEO of NITI for having hosted this session and invited me here. We spent this morning in the company of Mr. Yann LeCun and had a lot of detailed discussions on AI. And at least I'm glad that on this occasion I've been placed on the side of artificial intelligence and not natural intelligence, which is on the other side of the table for this afternoon. So, but in the course of the discussion, when we spoke in the morning, the interesting point that emerged was the extent to which the approach that the Government of India and NITI have taken with regard to the India AI mission and the extent to which it actually aligns with what his thinking has been on the subject and what he thinks about it. One of the main constraints that he identifies is the need for infrastructure, and that without compute we cannot achieve what we intend to. As we are all aware, in the India AI mission, out of the 10,371 crore rupees which is allocated, about 45% is meant for compute, and that is the main allocation that is there. About 4,500 crores is meant primarily for compute. The second point that he made was that alluding to the analogy of the cat, that presently LLMs only take note of a limited perspective of life, and so it is only a limited intelligence that gets translated into only one aspect of human intelligence really gets translated into an LLM, and we need to have a much wider multimodal model which can actually take note of all other things like videos, audios, images, and so on. So many other aspects of human experience which need to go into it before this technology can really advance and claim to be anywhere close to human intelligence. So the suggestion was that there's no point in wasting too much money in actually building another LLM. Yeah. And quite frankly, our India AI mission actually doesn't talk about an LLM at all. It talks about a foundational, large, multimodal model. So the option of actually building something other than an LLM is built into this. And to be honest, amongst the 7 pillars of the India AI mission, the one pillar that we haven't really pushed ahead with is the foundational model pillar, because we're waiting to see how the penny drops on this before we actually go into the next step. The other aspect which he emphasized was that applications are the thing that India needs to focus on, and in terms of applications, that's an important focus of what we're doing under the India AI mission. The fourth aspect, and I think that was probably the most important thing which he said, is the talent, and what we do with India's talent and how we sort of work around it. Actually, the event in the morning was where AICTE and was also present, and we were establishing a Center for Excellence on Gen AI in IIT Jodhpur, and also aligning the India AI Mission's Future Skills program into an MOU with Meta, and what we can do to actually train nearly 100,000 people in India. So that was a very important focus on what he said all of this morning, that we have tremendous talent, especially at the undergraduate level, and excellent institutions at that level. And we really need to build on graduate level research and PhD research, and we should be really looking to see whether we can excite industry more to invest in research. And really, amongst various initiatives that the government is taking, the Anusandhan, the National Research Fund, and also the newer effort which has been announced in the latest budget on industry-led research, all of those would actually fall in line or will be in line with the vision that Mr. LeCun has in terms of what we can do for research beyond a particular level, including for AI. So that is an important limb of what has been identified both as part of India mission and otherwise. And there was, of course, a very, very interesting discussion on the kind of safeguards and guardrails that are needed to guide the way that the India AI mission can work, or not just India AI mission, but AI in general can work globally, and the way that actually data sovereignty can be maintained if you have an open source AI model, and whereby the coding for the model can be made available on a decentralized basis at multiple locations, and the inferences and everything else can take place on the edge, and some of the data training can also take place on the edge, whereby the data need not go into a central model. Was another interesting point that he made. I hope I've quickly summarized what he said in the morning. I hope it doesn't sort of take away from all that he has to say. And there were many, many other things he said. But the reason I mention all this is that these were the points that really resonated strongly with all of us in MeitY and in the India AI mission, because this is more or less in alignment with the way that the India AI mission itself has come together, and at least an affirmation that we are more or less on the right track, I think was very important from an overall perspective for the country. And having said that, all of these elements are what we are really pushing forward in the India AI mission, and I would like to take this opportunity, because there are so many other ministries present here today and so many other agencies, and also NITI itself with your new Frontier Tech Hub, that the opportunity to actually create more applications is there in the India AI mission, and that is an opportunity which we should not miss out on. Its funding is available. Anybody needs something to be supported and quickly scaled up. It is something that under the India AI mission we can enable for a number of other ministries, because there are to be 25 use cases we need to develop, and it could be across a range of applications. And second, to provide the AI compute facility when the India AI mission is available to support the ministry's requirements there, because any application will require that. We would be more than happy to support all of that. And as we go forward, there are many of these alliances and many of these arrangements that we have with a range of companies and other entities who are working in this space, and Meta is an important partner in that aspect. Yesterday we were all sitting in Mumbai and we were having similar conversations with NVIDIA, for instance. So a range of entities with whom we have this partnership, and we really value this partnership specifically with Meta in terms of what it can do to support the overall goals of the India AI mission. So thank you again for having me.
Thank you very much. Thank you for hosting us and organizing this session. I don't have anything to say because Secretary Christian said everything about what we discussed this morning. So I can speak for just a few minutes on topics that are dear to my heart. So the first thing is about the future of AI, but short-term future, or perhaps the present, right? So what's happening at the moment is that the expansion that we see of the ecosystem of AI in terms of startup and large companies is quickly migrating towards open source platforms, namely the one produced by Meta called Llama, which is by far the most used of all the open source platforms. There are other providers of open source platforms, like Mistral, which is a small French company, which actually came out of Meta. Two of the co-founders are former Meta employees, and a few others. But what we're seeing is sort of the industry coalescing around open source platforms for a number of reasons. The first reason is that it's more flexible, it's cheaper, it's more secure, it's easier to customize, and for a company trying to deploy AI products, customization ability is really key. And so much of the business of AI today is taking an open source platform, whether it's a large language model or something else. It could be for image understanding or for speech recognition or other topics, and then customizing it for a vertical application in business or for customers. That's where the money is at the moment. That's where people are creating startups. We see this also in large companies. I was talking with, we visited the headquarters of Infosys 2 days ago, and we heard that Infosys clients, including large companies, actually want to use open source platforms for the same reason that small companies want it. So there is a general motion toward open source platforms and sort of a de-emphasis of proprietary models. And we see this as following the same template and evolution that happens on the market of operating systems 20 years ago or 25 years ago, where commercial providers were fighting each other to provide the infrastructure, software infrastructure for the internet. In the end, they all lost. I'm talking about Microsoft and Microsystems and a couple others. They were all lost because the entire industry adopted Linux as the foundation operating system for everything. And Linux now runs the world, except for a few laptops. But all the servers, all the internet routers, all the cell phone towers, all the cars even run Linux. The world runs on Linux. So that tells you something about the strength of open source, that generally progresses faster than proprietary systems. And you could think that things are different for AI, but in fact, it's even more the case for AI. And that allows us to go to the second topic I feel really strongly about, and I think is particularly relevant to India, which is that training foundation models today is really expensive. So large companies can afford it because it gets funded by other sources of revenue like ads in the case of Meta and Google. It's much more difficult for a smaller company like OpenAI to fund it. They have to raise money and they can't generate enough revenue to really fund the R&D going forward. So the future of independent foundation model outfits is unclear. What that means is that now there are two options. Either all the AI platforms will come from a handful of companies, proprietary systems that are produced by a handful of companies like Google and perhaps Microsoft / OpenAI, or we'll all coalesce onto open source platforms. And Meta, of course, is playing a very important role there, being the main provider of open source foundation models. Now, this is the future I'm seeing is that all of us, at some point in the future, will be communicating with the digital world or interacting with the digital world through AI assistants. Our entire digital diet will be mediated by AI systems. We'll be talking to them through our smartphones, through our smart glasses, and we're in there right now. I can talk to it. There's an AI assistant in there. It can answer any question. You can even take pictures. I'm not going to take pictures, but you can take pictures and perhaps explain to me what the document I'm reading is about, or translate it from one language to another. Soon, in the future, we'll have such glasses that have display in them, and they will be able to listen to us, but also listen to conversations that we are hearing, and basically produce real-time translation, basically subtitling everything we hear. And those systems, we already have prototypes that are capable of translating languages from speech to speech without going through language. That's important because there are many languages, including in India, that are not written, that are dialects that don't have a script, right? And so the technology is almost ready to actually enable people to speak in their own language and be understood by people who are kind of wearing devices that can do translation. So this could do a lot to preserve cultural diversity and allow people to preserve their culture. But for this future to exist, we need to have AI systems that are trained on all the data in the world, all the languages in the world, all the cultures, all the value systems. And it's very difficult to do this in a centralized fashion. So no entity as big as it is, whether it's Google or someone else, can really do this. For various reasons. The first reason is cost. It's expensive to train foundation models. The costs are rising. There's costs in collecting the data, cleaning the data, training the system using gigantic supercomputers that are expensive, as I'm sure Jensen Huang has probably told you. And then there is the expensive part, which is fine-tuning the system so that it behaves properly, basically, and it's can solve problems for everyone. Those costs are ballooning, and what I'm seeing in the medium term is that those foundation models will not be trained by a single entity; they'll be distributed. Okay, so there'll be potentially supercomputers in various regions in the world, independent. They won't belong to a single company. They belong to local companies, perhaps in partnership with governments. Those contributors will have local data in which they can train foundation models. So the training code will probably be shared among all of those infrastructures. But the way the distributed training might work is that we'll be able to train large models in such a way that it would be equivalent to training a single model on all the data, without the data being ever copied from one region to another. So Indian data can stay in India, and data centers in India can train on that data, but then participate in training a global model that eventually will constitute a repository of all human knowledge. So we need this because we need those financial models to really represent everyone on Earth, understand every language in the world, understand every culture, every value system. And we need this to be open because we don't want to have more populations, regardless of where they live in the world, to have access to only a handful of AI assistants that control their entire digital diet. That would be a danger to democracy. So we need a large, wide diversity of AI assistants. For the same reason we need a diversity of the press. We need several different sources, different biases, if I need to set the term. And the only way I can see that happening is if foundation models are trained in a distributed fashion. There's a big foundation model that knows everything about the world, and then people with various interests specialize them with their own center of interest, bias, culture, etc. So that's one aspect of the future. Another aspect of the future, and so to some extent, this will have this be kind of a win-win situation, because what you want is collaboration so that the AI platforms that are trained with everybody's data. But on the other hand, you want to keep some level of sovereignty, right? You want to keep your data locally. You want to have some control about how it's trained and managed. And with this kind of technique of distributed training, perhaps there is a way to do this and basically have, combine the advantages of everything. So this, of course, there's obstacles to doing this. You need local expertise of people who have the resources and the knowledge and the expertise to train models locally. You need the training code, which I think eventually is going to be open source. Right now, most of it is not, but I think eventually will be. And you need local efforts to collect data and filter data and everything. And also local efforts to fine-tune those systems so that they're useful. Okay, so that's one aspect. You need infrastructure, obviously, computing infrastructure. That's one aspect. The second aspect is that I'm absolutely convinced that within 5 years or so, the main design, the main blueprint of AI systems will be very different from the type of AI systems that we see today. So, in my opinion, large language models have a short shelf life. My friend Mano here gets chills when I say that because, he's spending an enormous amount of his own energy and that of his colleagues and actual energy actually training LLMs. But he and I agree that the AI story is not over. LLMs are not the end of the story. LLMs are very limited in many ways. They do not understand the physical world. They do not really have persistent memory of the type that humans and many animals have. They can't reason, they can't plan. They appear to be reasoning and planning, but they don't. They really regurgitate things they've been trained on. And that's the main limitation of those systems. They basically regurgitate. They can't invent new things on their own. They can solve new problems that they've never seen before. They basically just apply templates to things. And it's very useful. There's no question it's very useful. There's a lot of applications that in education, in health, in business, consumer applications, in I'm sure helping people in rural areas in various parts of the world access to medical advice and everything like that. So tons and tons of applications. But it's not the end of progress in AI. And my guess is that within 5 years, or let's say 5 to 10 years, to be safe, there's going to be a complete change of paradigm, where systems are going to be able to understand the physical world. And so we'll solve a gap that we're seeing today. We have systems that can pass the bar exam or write essays or summarize complex documents and answer complex questions. But we don't have domestic robots. We don't have self-driving cars. We don't have systems that are capable of accomplishing tasks that a 10-year-old can accomplish in the first time they try. like clearing up the dinner table and filling up a dishwasher. How is it that a 17-year-old can learn to drive a car in 20 hours of practice, largely without causing any accident, which is difficult in India, I'm sure. So it's, we're still missing something big about artificial intelligence for them to reach the level of human intelligence or something approaching this, or perhaps even cat intelligence, as you were saying. So it's half of a joke to say that current AI systems are stupider than the cat. They certainly have much less understanding of the physical world than the cat. And to some extent, it's a long history in computer science, but we're taking things backwards. We're training systems to play chess, solve complex math problems, solve differential equations and integrals and things like this, and pass the bar exam and write essays. But they don't have a foundation that tells them, they don't have common sense. They don't understand how the world works. They don't understand that an object cannot be in two places at the same time. They don't understand that an object cannot jump from one location to another. It has to go continuously from one location to another. And it's not going to do this spontaneously. Someone has to move it. I mean, there's basic things that we learn in the first few months of life as babies. And every animal knows that too. There is an incredible amount of background knowledge about the structure of the world. And that will require new technology that we're working on. In fact, the mission of the lab I created at Meta, called FAIR, used to mean Facebook AI Research, now it means Fundamental AI Research. That's the mission of this research lab. It's really bringing in the next generation of AI systems beyond LLMs, essentially. We call this program AMI, Advanced Machine Intelligence. We pronounce it AMI, because some of the leadership at FAIR is French, and AMI means friend in French. That sounds like it's relevant, but really it means Advanced Machine Intelligence. That's our name for AGI. You've heard that term in other contexts. We don't like to use the term AGI because we don't think that human intelligence in general, human intelligence is actually very specialized. So the term AGI is a misnomer. So once we have systems that can understand the physical world, basically being trained from video instead of from text, that can have persistent memory, can reason and plan, we may have a chance of eventually reaching human-level intelligence. And of course, inevitably, I get asked the question of how long it's going to take. The answer to this is we don't know, but with good hopes that we're going to get some good idea of when to get there within 5, 6, 7 years, something like that. What role could, what assets does India have, and what role can you play, and what's perhaps what kind of what work needs to be done? And I can use a template or at least learn from a phenomenon that I saw in France. So 10 years ago, we created a branch of FAIR in France, FAIR Paris, research laboratory in AI, owned by Meta. And this had an enormous effect on the local ecosystem. It basically sent the message. It's not a big lab. I mean, now it's 100 people. When we started, it was 10 people or something. We established a program by which we could host PhD students at FAIR in residence, so we could do their PhD by sharing their time between the university and the industry research lab. They absolutely love it because they get paid as engineers and they have access to enormous amounts of computing resources which they can't from the universities. And so we get all the best students. And they've been incredibly productive. And what this has caused is that it put in the mind of young students, I can have a career in AI, and AI is the coolest thing I can do at the moment. And so perhaps I should pursue graduate studies, a master's or a PhD, maybe to get a job in one of those labs. In fact, other companies started labs in Paris because of us. Google, and then a bunch of European companies did the same thing and sort of created the ecosystem. We are graduating 12 PhD students per year on average. They go into the ecosystem and they found startups, they work in academia, they work in large companies, they they work in various research labs, and it's basically pooled in the space of less than 10 years, 7 or 8 years. It pooled Paris as the hottest place for AI industry and AI startups in all of Europe. It's second to the US, essentially. So that's an interesting story. And what it tells you is that the pool is performed by ambitious research, the perspective of prestigious research positions for youth. They don't all get to that level, but the idea that they might get there motivates them to pursue graduate studies and then perhaps work in research for a few years and then switch to developing products or founding a startup. A lot of people from FAIR, from Google DeepMind, have left to create startups. People during their career very often transition from doing theory to doing research on algorithms to then developing products and then run a company. I mean, that's a fairly natural trajectory, which I have not followed, by the way. I stayed a researcher all my career. But I think that template could very well be reproduced in India. What I see in India is certainly a thirst, a hunger from young people in India to really participate in that project, to this incredible enthusiasm for AI among young people that I meet. The asset that India has there is a good technical education system at the undergrad level. What's missing is the perspective of careers in research, at least early on, for young people, that will motivate them to do a PhD in India as opposed to moving abroad. Okay, because there are more job opportunities for scientists abroad than in India. And that's partly, and by the way, this is true of Europe as well. It's partly due to the fact that if you do graduate study research, your only choice is basically to be an academic. The reason being that industry research in many parts of the world, outside of a few companies in the US, essentially does not exist very, very much. The companies that do ambitious research in information technology, where scientists can really do ambitious research at the same level as in a university, but have more computing resources and publish their work and everything, can be counted on the fingers of one hand. It's essentially Meta, Google, Microsoft, a little bit NVIDIA, but they're not really present. A little bit other companies that traditionally have done research like IBM and things like this. But that's it. No country in Asia, no company in Asia, no company in Europe. Well, they have small labs, which are not nearly as visible. Don't have the same level of prestige. And so having a lab belonging to one of those big companies or not in the country motivates the youth to actually pursue ambitious programs for their career. So that's, I think, there's two components to this. One of them is cultural and financial. The fact that companies in India and Europe need to realize that practicing research has enormous benefits, even if it's open research, particularly if it's open research. That's the way you can attract the best scientists. That's the way you can attract the best scientists to your country, if there are one, or get them to come back. And there is, of course, that's the cultural aspect, and then there's the cultural, the other cultural aspect of being willing to take risks and taking a bet on technology. Then there is, of course, infrastructure, and you can't do research unless you have good infrastructure nowadays in AI. And so that means having potentially private-public partnerships to build supercomputers that are dedicated to AI. The kind of supercomputer you need for training AI systems is different from normal computing infrastructure that a cloud hyperscaler will provide. You need high-end GPUs that are tightly coupled with each other. Basically, a supercomputer, high-performance computer. And then the third thing that's important is at some point, if India wants to serve 1.5 billion people with AI assistants, that is going to require an enormous computing infrastructure for serving AI systems, not training them, but running them for technical inference. And there, as much as I like Jensen, he doesn't have a monopoly of that. So there is a lot of different types of hardware that can be used for that, different software stacks. A lot of smaller companies that are working on building infrastructure that will bring down the cost of running AI assistants, so that a farmer in the middle of India can interrogate his AI assistant through smart glasses by just talking to it through using his local language, and ask for advice about agriculture or something of that type. Or the children can get education help from that, or he can ask questions to medical advice chatbot that where he can describe the symptoms, and then the system will tell that you'll go to the nearest hospital or you're fine. So it's tons of applications for consumers. It's going to require building up infrastructure, which probably the private sector is best positioned to do this, but probably needs help or incentives, possibly. And I think India has an important role to play in the training and build-up of the next generation AI system.
Thank you, Yann. We will open it up for your comments, questions. Lot to take over, so the floor is open.
I'd be great. I'll have to leave. May I just ask one question, request and answer? So we had Larry Summers here, and I think he's on either board of OpenAI now. He knows India well. And he just elliptically, as it were, made a reference to where he thought there was an opportunity in India. I may not have caught it right, and I wanted to relate it to the framework that you presented. He seemed to suggest that, yes, I mean, the compute is very expensive, and we may not need to be in the business of large language models, but he seemed to suggest that there were enormous employment opportunities in, as it were, selecting data that need to be fed for training models. So, if I understood that right, what does that part of the food chain look like? And particularly if you are talking now about data sources which are not digitized or not in English. So what is the nature of the opportunity and what is the scale of the opportunity?
Okay, I think he's right in one way. There are three components of the cost of building a foundation model. The first one is collecting the data and filtering it to get high quality data to train your model. If you train it with bad data, it's not going to perform very well. The second one is computation cost. You need to train those models, and that requires big infrastructure. And then the third one is what we call post-training or fine-tuning, and that consists in a lot of people playing with the model and then telling it when it's wrong and suggesting better answers, and then using that data to fine-tune the system. The cost. So for the first thing, collecting the data and filtering it, the main issue there is having access to data in a wide diversity of languages and cultures. And I don't think that problem can be, I think, as I said before, I think we need the entire world to participate in this, and not to just ship the data to OpenAI, but to be able to do a distributed training of common infrastructure that's open, which, by the way, OpenAI is not interested in. It's against the business model, right? They don't do open source because they derive revenue from people who pay to access their model. The second one is compute, and you've talked to Jensen about that. The third one, the cost of the third one is ballooning, and it's fine-tuning the system for particular use cases. So there's two phases to that one. The first one is for making sure the foundation models are useful, perhaps speak a number of different languages, perhaps don't spew nonsense or toxic answers. But also there is the next phase to that, which is in the hands of smaller companies to specialize systems for vertical applications. What we find is that, which OpenAI doesn't like, is that a smaller foundation model that is fine-tuned for a particular application will perform better than a large model that is completely generic. And so that goes against the idea that you need to have one single generic model doing everything for everyone, and certainly against the idea that those models will be proprietary and not really tunable. They need to be tunable. So that is more in line with the type of strategy that Meta is employing of distributing all kinds of different models, including very small ones that can be run locally on smartphones. Our latest model, Manu can talk about this, but our latest model is 1 billion parameter, and that eventually will run on the smartphone. So without having to communicate with the internet. So there's a lot of use cases for which that's sufficient. So yeah, I'm not sure. I mean, OpenAI is in this kind of strange situation that they have to derive revenue from the use of their model. Meta isn't.